Right, and here comes our third video on functions, and in this video we're going to be looking at composite functions. So we've gone through the definitions of range, domain, inverses, we've looked at graphical situations. Now we're going to have a look at composite functions, which is what happens when you slap two functions together, or when two or more functions are combined. So again, let's just go back to basics. There's a couple of functions that we've been referring to throughout these videos, two nice and simple ones. So let's just have a look at what happens if what we're going to do is apply f of x, and then we're going to follow that with g of x. So here we go. So if I take the value of 1, stick it into f of x, and out pops 5. And then what I'm going to do is take my value of 5, put it into g of x. So this value here is going to be g of 5, and g of 5 is 25 minus 3, which is 22, which is all fairly straightforward. If we do this algebraically, if I take a value of x, stick it into f of x, then out pops 4x plus 1. And now what I'm going to do is g of 4x plus 1, and g of 4x plus 1 is going to be 4x plus 1 squared minus the 3. And if we want to do a bit of tidying up on that, we end up with that result. And the reason I'm kind of taking my time to go through this is because there's an important result that comes at the end of it, which is I'm going to take my value of x again. This time I put x into here, and what comes out is f of x. And then what I'm going to do is take what we did each time at this step here. We took this value here and we put it into g of x. So I did g of 5, or I did g of 4x plus 1. And the point I'm working towards is here we're doing g of f of x. So what we've got is that. And generally speaking, when we write this, what we do is just take out of brackets, so that's just g f of x. Now the important thing there is to understand the order, because what it means is g f of x means we're doing f of x first, followed by g of x. So you apply them with the one that's nearest to the bracket first, and then the next one, and if we had another function in front of that, it would be that one again. So the order for applying functions is read right to left, not left to right. And that's really crucial, because as we're going to see in a second, gf of x is not the same as fg of x. Those are two completely different things, so order is absolutely crucial. Let's just demonstrate that point by doing fg of x. So this one up here is gf of x, which turned out to be this 16x squared plus 8x minus 2. Let's do it the other way around. So what I'm going to do is, first of all, do g of x, and put that into f of x. So I'm going to first of all write it as fg of x. I kind of like the brackets here, so it helps me with my thinking of what I'm doing. It is basically exactly the same as that, but it just helps organise my thoughts. It's entirely up to you if you want to include that, because essentially what this is f of x squared minus 3. So we've got that. And so what that means, I've got to take my x squared minus 3 and put it into here. So what I'm going to do is replace the x. I'm going to replace that thing with x squared minus 3. So I've got 4 bracket x squared minus 3 plus 1. Do a bit of multiplying out the brackets, and we've got 4x squared minus 11. And clearly that thing there is completely different to this one here. So that's kind of the purpose of this slide, was just to really illustrate the point that firstly, the order, you read them kind of the wrong way around, and secondly, the fact that order is vital, because gf of x is not the same as fg of x. Right, on we go. So quick example. So given those two functions, we've got f of x and we've got g of x, and we need to solve an equation. We've solved fg of x equals 1 over 9, and we're going to leave our answer in terms of e. So here we go. So first thing we need is fg of x. So that's do g of x first and then put it into f of x. So g of x is ln x plus 2. And that's got to go into f. So again, there's my extra brackets into how am I thinking. That's what we're going to be doing. So I've got to, every time I see the x in here, I've got to replace it with ln x plus 2. So we get that. And now, so that thing there is our fg of x, and we're told that that is equal to 1/9, which allows us to form that equation. Multiply the 9 over, take that bit over there. There we go. And now we've just got a bit of rearranging to do. So let's bring the 6 over, make 15, divide by 3. So we end up with 5 equals ln x plus 2. Now let's just reverse the logs. So that's going to be e, which is our base of our ln, to the power of 5 equals x plus 2. So therefore x equals e to the power of 5 minus 2. And there we go.